We present uKnit, a position-aware reconfigurable machine-knitted wearable for gestural and passive sensing using electrical impedance tomography. Inspired by gaiter scarves that are tubular, multifunctional, and affords reconfigurability, uKnit is a machine-knitted wearable that can morph into different functional forms for different contexts and uses, such as scarves, headbands, and knee bands. After it is placed on different body parts, uKnit can detect its position from a simple touch gesture. uKnit adapts and enables active sensing such as touch and deformation gestures, and passive sensing such as monitoring respiratory rates and body postures. Here's the fabrication process. We use industrial machine knitting for scalable manufacturing, off-the-shelf conductive yarn for sensing, non-conductive acrylic yarn for insulation and connections, and a thinner rayon yarn for decoration. To embed the sensing capabilities without post-processing, we use the intarsia knitting technique. To connect the sensing board to the knitted fabric, enameled wires are first wrapped around and soldered to the washers. Then the washer electrodes are glued to the fabric using conductive epoxy. To route the wires to the sensing board, we hand sew the wires in serpentine traces. Now we have the sensing fabric. We chose electrical impedance tomography to sense a rich set of gestures and minimize the number of wires for connections. Impedance captures resistance, capacitance, and inductance. uKnit relies on resistive and capacitive changes. The visualizer shows 4 blocks of signals corresponding to our 4-patch 8-electrode each prototype. For each adjacent pair of electrodes, the voltage differences between 5 other pairs of electrodes are measured. This results in a total of 160 channels of signals. The 4-patch design gives coarse localization. Touching a single patch results in changes within a patch. Touching overlap patches result in similar changes between patches. Only a subset of signals are shown for readability for the rest of this video. We evaluated the sensing performance. For the location detection model, we evaluated 4 calibration gestures: grab, swipe, pinch, and touch. Though they all had similar performances, we selected touch as it is the simplest gesture for potential seamless integration. For the gesture recognition model, uKnit is able to distinguish between 7 gestures: pinch, grab, rest, top touch, middle touch, bottom touch, and swipe. For respiratory rate monitoring, uKnit has an average error of 1.25 breaths per minute. For sitting posture monitoring, uKnit can distinguish between sitting straight versus slouched with 86.2% accuracy. We will show some example applications with real-time predictors. uKnit can be placed at different body parts when the user's hands are unavailable. Here, pressing the elbow against the body helps to scroll the recipe. uKnit can also log exercises. A knee bend configuration can count the number of squats. Even for the same control, the position and gestures can be customized for different scenarios. When running, the user controls a headband music player using touch gestures. On a cold day, the user can reconfigure uKnit to be a hands-free neck scarf music player. Instead of carrying several distinct devices, users bring uKnit as a single position-aware reconfigurable wearable.